Hello everyone. In this video, we are going to do the laws of indices. And for that, we just need to discuss a few basic terms before we proceed on to the laws of indices. And finally, we will be doing some questions as well. So let's say we have A times x to the power b. This A is called the coefficient of x power b. The coefficient of x power b. This x, which has some power, we will refer to it as the base. And this b, which is the proper term is exponent, but usually saying it's power of x, this is also convenient to say. Now I'm going to explain the laws of indices, and the first rule is if the same bases are multiplied, then their powers are added. You can see here base a to the power m times base a to the power n. Same bases are multiplied, so we will add their powers, and the list goes on like that. You can easily relate if same bases are divided. For multiplication, bases are added, but for division, the bases will be subtracted. But the thing is, subtraction is order sensitive. So which power would you subtract? Would you subtract m or n? Usually this is the power which is after the division sign. We can write the same division situation as like that, a power m over a power n. And just a bit more detail here. If I transport this a power n from the denominator to the power n to the numerator, this a power m remains as it is, and whatever base is shifted from across the numerator and denominator of the same fraction, the sign of its power is reversed. And you can see, as rule number one say, same bases multiplied, you will add the powers m plus negative n, which again results into m minus n in the power. From there, we have in our list another rule that if it is a power positive m in the numerator, you can shift this in the denominator of the same fraction, and that causes a reversal in the sign of the power. Similarly, if it is negative in the numerator, negative power in the numerator, you can always reveal this hidden one, and then you can shift this a power negative m down in the denominator of the same fraction, and it also gets a reversal in the sign of its power. It's quite easy to understand. Any number to the power 0 is 1. You can see that if it is 100 to the power 100, let's say, and you divide by itself, you do get 1. And if you apply the laws of indices, look at the rule number 2, 100 to the power 100 minus 100. So any number to the power 0 results in 1. Our fifth rule is power of power. If we have a power m and then we have another power n, we will simply multiply these powers. You can see here, we can always understand the power as the number of times it is multiplied. For example, a square. This square means the same base is going to be multiplied by itself 2 times. A cubed would mean the same base multiplied by itself 3 times. So if it is a cubed, it means a is multiplied by itself a times a times a. And then if it's a squared, the same base is multiplied by itself that many times. And you can see that same bases are multiplied. All of them have 1 in their power. There are a total of 6 a's multiplied with each power 1. And thus we get, add all the powers according to rule number 1 here. Same bases multiplied, you add the powers, a power 6. Instead of doing that detailed working, you can simply multiply these powers and you'll get power of power, and it indicates that you multiply the powers. Next up is rule number 6. Rule number 6 is quite interesting because it leads to a difficult or a common misconception in most students. If it is same power but different bases are multiplied. Here we were dealing with same bases with different powers in all these, and here in rule number 6 we have same power but it's a product of different bases. You can say this whole power is distributed to each of the different base being multiplied. So it's a power m times b power m. Similarly, if it's the whole power, we call them the whole power of a product, and now whole power of a fraction. What would you get? Again, by the same way, this whole power is distributed to each of the numerator and the denominator. But this is most commonly misunderstood by students, that if it is the sum or a difference having some whole power, they also do this same mistake. They just simply distribute this a power m plus or minus b to the power m. And this is a non-example. Please make sure that you take careful note of this. If the sum or difference is having some power other than 1, then we cannot distribute like that. Let's take an example. If it is a plus b whole squared, then square means this a plus b is multiplied by itself twice. And this one leads to a times a is a squared, a times b is ab, b times a is ab again, and then b times b is b squared. We get how many terms? 3 terms. So if you just remember that if we have a binomial, if it is negative here, we will get a situation like that. If it's a binomial and you're expanding it to some power, you will always have one more term than the power here. If it is 2 whole power, you're getting 3 terms. If it were 3 power, you would have gotten 4 terms. So considering this whole power property, it's only applicable for a product or a quotient, but not for sum or difference. Now let's take a few examples here. If it is a power 7 to the power 3, you can see here, this is power of power, rule number 5 here. And we simply multiply the powers. A power 7 times 3, and we will say that a power 21 is our final answer. Next up is p times q squared times p cubed q power 4. As a matter of fact, whenever you write ab, it means they are multiplied. So if you write p q square, it means p is multiplied with q square, just for your clarity, and they all are multiplied. Keep an eye on rule number 1, same bases multiplied. So I can always shuffle or switch their places in case of multiplication. Just to show you, I can write the product of p and p power 3 in one place and q squared and q power 4 in another place. As a result, we get p power 4 because same bases are multiplied. You'll add the powers for p, similarly for q, and in the answer, you must not write this product sign. So final answer should be p power 4, q power 6. Lastly, it's c. First of all, if it's a fraction, you would want to cancel any numbers, and 2 ones and 2 fours are 8. So it's 4 in the numerator in terms of numbers. And then we have the powers of a. Just keep an eye on powers of a first. So it's a divided by a power 4. A power 1 is divided by a power 4. And by rule number 2, we can always transport the smaller power. It's ideal that you shift the smaller power from its position. So I'm going to bring this a power 1 down in the denominator. just to show you, and we'll get a power 3 in the denominator. And let's say I'll write here a power 4, b power 4, just to show you. You don't need to necessarily show all these steps. You can directly say that if it is 1 power in the numerator and 4 powers in the denominator, you'll take the difference of powers and you're left with 3 powers for a in the denominator. That's the shortcut that we want to see. Similarly, b power 4 in the denominator, b power 5. So the difference of powers, you're left with 1 power of b in the numerator. Again, you don't show 1 as your answer for in the power. So it's 4b over a cubed. It's always ideal that you represent your answer in positive powers. I'm going to give you another example, which was not listed above. Let's say we have a to the power, a divided by b to the power negative m. It's ideal that you represent your final answer with positive powers. Now, one way is if you look at the rule number 7 here, if it's the whole power of a quotient, you distribute this power to each of the numerator and denominator. If I were to do like that, I would give this negative power m, negative m to a in the numerator and b in the denominator. And then if I have to make each of these powers positive, I'll bring this b power negative m to make it b power positive m, and this a power negative m down to get it a power positive m. This could be our answer. This is just this an example. But a smart way out is, I'll put 2 stars for that. Why don't you shift this whole fraction at the very start? This will become a handy trick here. If it is a over b to some negative power, a fraction to a negative power, you reciprocate the fraction at the very start. And you can see that if you distribute the power now, it's b power m over a power m. I'll be posting more videos on laws of indices and few more questions. So thank you for watching.